The Milrow Event took place in Alaska on the island of Amchitka. Amchitka was under consideration as a supplemental site for the testing of high-yield atomic devices. Alaska is a big state. This way we can see just how big. It is about as far from Amchitka to Juneau, which is the capital of Alaska, as it is from Washington, D.C. to Albuquerque. The nearest non-military habitation is on Amchitka Island, here about 300 miles east of Amchitka. As a prospective test site, remoteness is one of Amchitka's most attractive features. The purpose of the Milrow Event was to test an island, not a weapon design. Before we could go ahead with the testing program, some questions had to be answered, and Milrow was tailored to answer them. Could contained underground nuclear tests be conducted with no hazard to off-island people and within the constraints of the Limited Nuclear Test Ban Treaty? Could these activities be conducted without a serious adverse impact on the wildlife of the island? Could we support a test operation in the forbidding environment of Amchitka? Amchitka and the other islands in the Aleutian chain were formed millions of years ago when lava spurted up through a giant fissure in the ocean floor. These tundra-covered islands now stretch between two great continents, like an emerald necklace dividing the Pacific Ocean from the Bering Sea. The easternmost islands have a flora typical of the Alaskan mainland to the east, while the western islands, which include Amchitka, have many Asiatic features. The Aleutians were once described as the melting pot for faunal elements from two continents, not yet reaching equilibrium. Most of the islands are mountainous, the emergent peaks of a submarine mountain range. The larger islands, of which Amchitka is one, are dotted with lakes and cut by streams. Their irregular shorelines have boulder and black sand beaches with rugged, rocky cliffs. Offshore, there are small islets and reefs where the water conceals extensive kelp beds. The names Attu, Kiska, Adak, and Amchitka brought memories of World War II to those working on the island, and they were reminded daily by the many moldering buildings, wooden walkways, gun revetments, and miles of barbed wire that still remained there. When the Japanese occupied Attu and Kiska, the United States built up garrisons in the Aleutian chain, and Amchitka served as our westernmost air base. Although Amchitka was bombed and strafed many times, it was never invaded. Perhaps because the American forces had a highly classified new tool with which to detect incoming raiders. Housed in an innocent-looking water tower like this one was one of the first tactical radar units. The water tower took a few machine gun bullets. Who could resist a target like this? But no Japanese pilot ever wasted a bomb on it, saving them for more strategic targets. The Aleutian campaign ended when the United States bypassed Kiska and successfully invaded Attu. With their supply lines cut off, the Japanese abandoned the base at Kiska. During this period, the population, which was comprised solely of Army and Army Air Force personnel, reached approximately 25,000. Many runways and hard stands are one portion of this World War II legacy. With the addition of modern lighting and navigational equipment, Baker Runway still serves the island as modern jets and cargo planes bring the men and materials necessary for the island's new role. Amchitka is now served by two airlines. Reeve Aleutian Airways, bringing in passengers, freight, and mail on Mondays and Fridays, and an Alaska Airlines AEC charter flight twice weekly with passengers and freight and a weekly freight run. Heavy freighted equipment are brought from Seattle and Anchorage by barge to Constantine Harbor, where there are good deep water docks. This harbor also provided safe berthing for the civilian oceanographic ships that participated in the test. The main camp, as well as the administrative and warehousing compounds, are located on the south side of the runway. The living area of the main camp can accommodate up to 800 workers in comfortable two-man rooms. In this complex, there are also the eating and recreational facilities. All the buildings in this living area are connected with covered walkways so that during inclement weather, the occupants can visit the cafeteria or recreational areas without going outdoors. Connected buildings are a welcome feature in an area like Amchitka, where the winds average 20 to 25 miles per hour, and winds up to 100 miles per hour are not a rarity. Another relic of World War II are the hundreds of telephone poles that provide a commanding perch for the eagles that populate the island. Protected by the Bald Eagle Act, these birds have little fear of the island's newest species, AEC. The bald eagle, who mates for life, may be observed roosting on the poles. Or he may be seen soaring between the poles and over the ocean on the persistent Arctic winds. Family groups survey their treeless domain from small tundra hillocks with a sense of security uncommon in other areas of the world, where man had hoped to endow himself with their strength and dignity through the possession of their talons and feathers. Underneath the alpine tundra, the soil consists mainly of clay and organic material, sometimes reaching a depth of 20 feet. Beneath this lies the backbone of the island, which is characterized by volcanic materials of various kinds. The flat southern end of the island was chosen for this first major test, where the emplacement hole was drilled 36 inches in diameter to a depth of 4,000 feet. By far, the greatest number of tests have been fired in vertical holes, which had been backfilled with sand and gravel. This was the method employed for this calibration experiment. At noon on September 15th, the test device was delivered from the assembly area to Ground Zero. Amchitka cooperated by surrendering one of her infrequent, truly good days. The insertion of the device followed the same proven procedure used by the Los Alamos Scientific Laboratory so many times before at the Nevada test site. Within a few hours, the device was ready to start downhole. Using downhole lowering techniques developed and proved at the Nevada test site, the lowering began. This process would continue for the next 2 days. The only departure from the Nevada methods was the use of spools to supply the instrumentation and firing cables. At Nevada, the cables are merely laid out on the ground prior to use during lowering. In Amchitka, it was feared that the rains and moist weather might adversely affect the cables. Los Alamos engineers developed this system using pre-spooled cables which could be stored in an array inside a building built at Ground Zero. As the device is lowered, the proper amount of cable is paid out from the spools. In this case, the array consists of 9 spools. Time of arrival gauges and slifer cables were attached to the load-bearing cables. "23 working hours later, the device arrived at the bottom of the 4,000-foot hole. And after a 15-minute signal dry run, the backfilling operations could begin. Backfilling a 4,000-foot shaft to contain a nuclear explosion is not just a matter of pouring sand in a hole. The containment techniques used during the Milrow Event were a demonstration of the state of the art. During this operation, a total of 1,500 cubic yards of backfill material was used. The backfill was composed of 90% coarse gravel, averaging about 3/8 inch in diameter. The remaining 10% was a mixture of fine sand and bentonite. This material was poured into the hole at carefully controlled intervals, with breathing periods in between to allow the fill to settle. Again, methods proved at the Nevada test site were used, but concessions had to be made to the weather. In order for the fill material to settle at a consistent and known rate, the moisture content must be very low. To meet this condition, 1,500 cubic yards of pea-sized gravel were dried at a batch plant on the island and packaged in these rubber containers. Each bag will hold about 10 yards of gravel. The amount of bentonite and sand that would be needed was also dried and packed in bags. These were stored at ground zero, and the necessary amount of fill material at just the right moisture content was on hand when backfilling began. Spaces for 4 bags were provided above the conveyor belt that carried the fill material to the hole. The conveyor belt was covered so that operations could continue during the frequent rainstorms. Each full bag weighed 10.5 tons. As the hole filled, at about 25 linear feet per bag, rest periods were observed. 3 minutes of fill, and then 3 minutes of rest to allow the material to settle. The rate of fill began at 35 feet per hour, but as the hole filled, the rate was increased to a maximum of 120 feet per hour. The first 1,000 feet were filled entirely with gravel. The engineers then switched to 90 feet of gravel and 10 feet of sand and bentonite. This schedule was continued until the last 28 feet, when 20 feet of fine sand was used with 3 feet of gravel over it. The last 5 feet were left open. The entire backfilling operation took 7.5 days. This unique backfilling operation permitted work to continue in all kinds of weather. The annual precipitation on Amchitka is between 30 and 35 inches. In general, no other area of the world has worse weather than the Aleutian Islands. A typical day on Amchitka is characterized by overcast skies and high winds. Cloud ceilings average under 1,000 feet, and visibility is less than 3 miles during 60% of the year. A diagnostic recording complex was constructed just outside the area of anticipated collapse. Measurements were made in the same manner as in most underground detonations. The only departure for normal methods was the use of a specially designed film holder. Because there was some concern that there might be physical damage to the equipment in the recording complex, and also because of the possibility of exposure to moisture after the shot, a hardened film holder was developed for use in the recording cameras. In this design, the film is fastened to a curtain under tension. Moments after the record is made, a solenoid holding the curtain in place is tripped, and the film is wound into a waterproof cassette. This cassette is much more rugged than a conventional film holder and would undoubtedly withstand a severe ground shock. This little fellow is called Amchitka by native Alaskans. We call him a sea otter. In 1938, he was believed to be extinct, but then a few of his number were sighted off the coast of Northern California. Protected by careful management, he is making a comeback all the way from the Channel Islands off California to the tip of the Aleutian chain. Sea otters are hunted in limited numbers now, and a pelt has been known to bring over $1,000. They are the only aquatic mammals in the Aleutian area not protected from the cold by a layer of blubber. They must depend on their thick, luxuriant fur to provide the necessary insulation. The little animals are constantly cleaning their fur, or if they did not, it would become matted, and they would soon perish in the cold waters that are their home. The sea otter was the subject of one of the studies conducted during the test. Cages were placed on the ocean near surface ground zero. They would contain sea otters, placed there shortly before the event. The purpose of this experiment was to determine if the shock and overpressure resulting from the detonation would pose a possible hazard to otters in the water offshore. A very simple method was used to record the overpressures the otters experienced. Empty sealed cans, the size and shape of an ordinary beer can, were attached to the sides of the cages. By measuring the volume of the can after the test, it was possible to determine the overpressure it had been subjected to. The cages were constructed to contain 5 sea otters each. Floats fastened to the sides of the cages held them half in the water and half out. Many other measurements were also made in the ocean near surface ground zero. Divers clad in double wetsuits worked in the 45-degree water for many hours, emplacing 10 tide gauges. Each gauge was a self-contained unit with its own power supply and a recorder for data storage. The divers placed these gauges at depths from 60 to 80 feet, at various distances from ground zero up to 6 miles. Each gauge was positioned on a concrete base and leveled. The gauges were to record any prolonged changes in pressure, such as long-period waves or tides. They would also detect any permanent vertical ocean floor displacement. The gauges were placed at these locations offshore. The island is cut by 2 faults in this area. This one is called the Rifle Range Fault because of its proximity to an old rifle range, and one here that is unnamed. Scientists believe that any lifting or displacement of the ocean floor that would occur would be in this area, or to a lesser extent on the north side in this area. A recording station was located in this area on the north side of the island. Gauges placed on the ocean floor detected rapid transient phenomena such as shock, velocity, and overpressure. Signals from these gauges were transmitted to the recording station by cables laid on the ocean bottom. A similar array of instrumentation was also deployed offshore on the south side of the island. These measurements, for the most part, would be useful in the bioenvironmental studies. Tsunamis are known to have resulted from very large earthquakes centered near Amchitka, and waterways several feet higher than normal have been observed in other nearby Aleutian islands. None of these waves, however, have produced distant damaging effects. To monitor these phenomena, ultra-sensitive seismic detectors were deployed on the ocean floor and on some of the islands in the Rat Island group. The population on the island diminished as time for the event drew near. On the evening of D-2, only 239 men remained. Of these, 154 moved to the control point, 35 miles north, where their presence was essential to the completion of the test. The other 178 were evacuated to the aircraft carrier Princeton. Since the evacuation took place over 25 miles of cold Arctic Ocean, the evacuees were required to wear yellow rubber exposure suits. These poopy suits, as the Navy called them, don't come in sizes, and as the men donned them, the scene looked very much like the beginning of a potato sack race. Four Marine helicopters were used in this operation, 3 carrying loads and 1 empty one flying escort for rescue duty if needed. After the helicopters landed safely aboard the carrier, the men removed their exposure suits and were shown to quarters below deck. The Princeton would be their home until after the event. A road running the entire 42-mile length of the island connects the control point and testing areas with the base camp. From the low tundra plateau covered with shallow ponds and small lakes at the southeast end, the road winds northwest, following the high ridges to the rugged mountains where the ground is covered with moss grass and sage. Once the protective tundra is broken, the soil underneath is immediately subject to erosion and becomes very unstable. In addition, it takes many years for the tundra to overgrow an area that has been disturbed. For these reasons, in the interest of conservation, it was decided to use the old World War II infantry road as the bed for the new road. The control point is a completely self-sufficient camp where more than 150 men can live and work during the last few days before a test. In the unlikely event of a massive vetting or similar contingency, provisions have been made to provide cover for the occupants until evacuation could be effected. The control point becomes the nerve center of the operation shortly before the scheduled time of firing. The timing and firing facilities are located in this compound. Although the actual detonation of the device was accomplished through hard wire signals, many remotely operated instruments were activated by a radio signal. These radio signals also went out from the firing console. The weather, always an important factor, was excellent on D-Day. A gentle wind from the northwest favored the area with the best possible conditions. Aboard the Princeton, newsmen and official observers listened as the countdown progressed.
25 seconds.
10 seconds.
9, 8, 7, 6, 5, 4, 3, 2, 1. 0 time.
Although the men aboard the Princeton, 30 miles from surface ground zero, felt a shock, there was no discernible water wave at that distance. An aerial survey after the shot revealed nothing unexpected. The building at ground zero showed extensive damage. It was estimated that the ground in this area had been displaced upward 13 feet. It then fell to a point 13 feet lower than its original level. After this violent oscillation, it came to rest 1 foot lower than its original position. A day and a half later, the ground had subsided another 19 feet. Unlike the subsidences after Nevada test, which generally occur in a sudden and massive manner, Milrow subsided slowly and gradually. This lake, about 150 yards southeast of ground zero, had partially drained and moved northwest. A large fissure was visible in the old lake bottom. The diagnostic station sustained severe structural damage, but did not collapse. Roads in the area cracked and buckled in some places. In one place, a lake had overflowed one of the roads. A large portion of the cliff immediately behind the recording station broke away and fell into the ocean. Damage from the Milrow event was confined to the portion of the island where the experiment had been conducted. No significant aftershocks were recorded outside the immediate area. Beyond 40 miles, there were no detectable long-period waves formed as a result of the test. Scientists found the sea otters swimming about in their cages, eagerly awaiting their next meal of frozen sole. The eagles, although startled by the ground shock, returned to the telephone poles to continue their watch over the tundra. The detonation had had an explosive force of about a megaton of TNT and registered 6.5 on the Richter scale, as had been publicly predicted. Milrow had proved the anticipated answers to the questions. There had been no hazard to off-island people, and the test had been conducted within the constraints of the limited nuclear test ban treaty. There had been no significant adverse impact on the wildlife of the island. In spite of the environment on Amchitka, the test had proceeded exactly on schedule.